A switch is a network device that operates at the data link layer, layer 2, of the OSI model. It is designed to connect multiple devices in a local area network, LAN, and facilitate the efficient and intelligent forwarding of data packets. Switches have largely replaced older network devices like hubs and bridges due to their enhanced performance, advanced features, and scalability. Here are some key points to understand about switches. Packet switching. Switches use packet switching to forward data packets between devices in a network. Unlike hubs that broadcast data to all connected devices, switches examine the destination MAC, media access control, address of incoming packets and forward them only to the appropriate port associated with that address. This process significantly reduces network congestion and improves overall network performance. MAC address learning. Similar to bridges, switches employ MAC address learning to build a forwarding table. When a switch receives a data packet, it examines the source MAC address and associates it with the port on which it was received. This information is stored in the forwarding table, allowing the switch to determine the appropriate port to forward packets destined for that MAC address. This learning process enables switches to intelligently forward packets based on MAC addresses. Forwarding and filtering. Switches forward data packets selectively to the intended destination devices based on MAC address information stored in the forwarding table. If a destination MAC address is known, the switch forwards the packet only to the port associated with that MAC address. If the MAC address is unknown, the switch floods the packet to all ports except the incoming port, allowing the packet to reach its intended destination. Subsequent packets with the same destination MAC address are then properly filtered and forwarded based on the MAC address learning. Virtual LANs, VLANs. Switches support the creation of virtual LANs, or VLANs, which enable network segmentation and improved network management. VLANs allow the logical separation of devices into different broadcast domains, even if they are physically connected to the same switch. This segmentation enhances network security, simplifies network administration, and reduces broadcast traffic. Quality of service, COS. Switches often include COS features to prioritize certain types of network traffic. COS allows the switch to prioritize critical data such as voice or video traffic, ensuring that these time-sensitive applications receive sufficient bandwidth and low latency. By prioritizing traffic, switches can optimize network performance and ensure a better user experience for real-time applications. Managed versus unmanaged switches. Switches can be categorized as either managed or unmanaged. Unmanaged switches are plug-and-play devices that do not require any configuration. They are typically used in small networks where simplicity is preferred. Managed switches, on the other hand, offer advanced configuration options, network monitoring capabilities, and remote management features. They are commonly used in larger networks that require granular control and oversight. Layer 3 switches. In addition to Layer 2 switching, some switches also incorporate Layer 3 functionality. These Layer 3 switches have routing capabilities and can make routing decisions based on IP addresses, allowing them to connect different IP networks together. Layer 3 switches provide inter-VLAN routing and simplify network design by combining switching and routing functions in a single device. PoE support. Power over Ethernet, PoE. Switches provide power to network devices, such as IP phones, wireless access points, and surveillance cameras, through the Ethernet cables. This eliminates the need for separate power cables and allows for easier deployment of network devices. Switches play a critical role in modern networks by improving performance, enabling network segmentation, enhancing security, and facilitating advanced features like VLANs and COS. Their versatility and scalability make them an essential component in building efficient and flexible network infrastructures. Thanks for watching.